Hi, this is a quick introduction to the stellar physics topic at Advanced Higher Physics. The first part that we're going to be looking at is going to be to do with stars. Okay, so why stars? Well, stars are fairly obviously the thing that we see in the night sky. They're the most obvious thing if you walk outside, other than the moon. They're something that you look up at, and for many thousands of years, they've been a source of fascination, and they've driven science forward, in particular physics and astronomy. We use stars to find out about the universe. The light from stars and the light from galaxies tells us a huge amount about how the universe might have started and also how it might end. Stars make most of the chemical elements around us. We are basically made of stardust, and almost everything in our world has been basically formed inside a star. We're also only alive because of our star's energy. The energy that comes from our star, the sun, keeps us warm and gives our planet energy. So, are they all the same? Well, the short answer to that is absolutely not. We're going to look at the differences between stars, but to give you a wee bit of an idea about what we're going to be doing here, the smallest star is about 5% of the mass of the sun, the smallest star that we've found so far, and it's around about 12% the size of the sun. Now, there are actually, I think, smaller stars than the ones that are in this picture, but it's hard to get an uncopyrighted image. So this is the one that I've used, but it gives you a wee idea. The smallest stars are around about the same size as Jupiter. And indeed, if Jupiter was a little bit bigger, then the gravitational forces acting on the atmosphere in Jupiter would actually be enough to start nuclear fusion, which would actually make Jupiter into a sun. So Jupiter is about as big as a planet can get before it actually becomes a star. At the other end of the scale, the star with the largest mass is about 315 times the mass of our sun, and the star with the largest size, which is not actually the same one, is around about 2,600 times the radius of our sun. So radius and mass don't actually necessarily directly link up. They sometimes do, but we'll have a look at that in more detail later on. This is the largest star by radius. It's Canis Major, and just to give you a wee idea, if we put the sun next to Canis Major, then it would just be literally a wee pixel. It would be this wee dot, and the dotted line there gives us an idea about Earth's orbit. So that gives you an idea about the size of Canis Major. So if the whole solar system was basically dropped inside Canis Major, all of the inner planets would be completely engulfed. And to a certain extent, our sun is going to do something slightly similar, not get to nearly that size, but this is something that happens to stars at certain points in their life cycle, which again we're going to look at later on. And the last bit that we're going to be looking at is that stars have different temperatures and colours, and they have different lives. So this life cycle is something that we're going to be looking at. We're going to look at how stars change during their lifetime. And lifetimes for stars can change an enormous, it can be very, very different. Some stars have a lifetime of only a couple of million years, going all the way up to, we think, about 10 trillion years, which is several, basically about 1,000 times the age of the universe up to now. So as you can see, there's a big difference, and this is something again we'll look at later on. This is a definition of stellar physics. This is really what we're looking at in this topic. Stellar physics is the study of stars throughout their birth, life cycle, and death. So we're really trying to look at the processes and what actually happens to stars, how they change as they get older. And these are, broadly speaking, some of the things that we're going to be looking at. We're going to be looking at how we can classify stars, how stars were formed, how they live and how they die. Obviously, they're not living things, but they do have a kind of a life and a death. We're going to be looking at what goes on inside stars, the process of nuclear fusion that creates everything around us, and we're going to look at brightness and luminosity.